Very good morning. We continue sampling distribution. Today we discuss T distribution, F distribution and central limit theorem. And you see that some amount of sampling strategy also will be completed today. And I'm expecting that you all will be able to grasp the concepts, particularly in last lecture and today's lecture under this statistical distribution, Z, chi-square and F distribution. These are very, very important distributions. In addition, the central limit theorem is an extremely important concept in basic statistics. Let us see next.
Now let us see T distribution. T distribution, when we will use T distribution? First we have to understand when we will be using T distribution, then we will see the uses of T distribution, then again I will show you the table, how to use table to find out the different critical values for T distribution. You see here, if Z and xk are independent, normal and chi-square variable. So, we are now considering two variables. One is normal variable, that is unit normal, that is Z. Another one we are talking about chi-square. Let it be chi-square with k degrees of freedom. Fine. Now, you create another variable which is T, which is Z by square root of chi-square k divided by k. Now, in your development process, suppose when you are developing model, if you find that you have created some variable which is of this form, that normal by square root of chi-square divided by its degrees of freedom, then this quantity, the T, will follow T distribution with k degrees of freedom. T distribution with k degrees of freedom. So, that means T distribution case also degree of freedom will come. Degrees of freedom is very important for chi-square distribution, for T distribution also. And you see it is the shape of T distribution, it is similar to normal distribution. When your this side, the degree of freedom will be infinite, that will exactly match with normal distribution. What is the mean value of T distribution? You are not getting. See Z, what is the mean value of Z? 0 mean. So, that mean value divided by something 0 is coming. So, what is happening here? The T distribution mean value is 0 and standard deviation value is square root of k by k minus 2 and k must be greater than equal to 2. And you see that this one here, in the diagram itself, the mean value is 0. What it is? What is its use?
Actually, it takes both mean and standard deviation into account.
Which one? It is there, no? Basically, it takes what is the parameter of T distribution? What is the parameter of normal distribution? Mu and sigma square or sigma? What is the parameter of T distribution? That is the case. What is there here? See, everywhere k is there. You see the function gamma k plus 1 by 2 k, here k, everywhere k is there. So, that means the parameter of this distribution, T distribution is the k, degrees of freedom, and you are getting, that is why mean is 0 and sigma square in terms of k. Getting me? So, you will know the parameter from the PDF only. In T distribution PDF, all the all other values are constant. T definitely the random variable, otherwise for other things you see that pi is a constant one, and that is that pi, otherwise only k is there everywhere, gamma distribution is given. Getting me? Now come back to this use. What is the use of, when do you use T distribution? Now let us see that the T is like this, that x bar minus mu by s by square root of n. We have created this type of composition. How it will, why it will come, or why how it will come, I am showing you one thing, that when we talk about the distribution of x bar, so x bar is 1 by n sum total of xi. Then I asked you what is the expected value of x bar, you said that expected value of 1 by n sum total of xi. So, that means 1 by n expected value of x1 plus expected value of x2 plus expected value of xn. What is the expected value of x1? All are mu. If x is normally distributed, every observation will be normally distributed with the respective mean. So, it is basically n mu by n, that is mu. So, we say that expected value of sample average is mu. Now, what will be the variance component? If I want to know variance of x bar, that means this is nothing but variance of 1 by n sum total of again xi. So, as I said that variance, if you that 1 by n square, then variance of x1 plus variance of x2 plus variance of xn. x1, x2, xn all are normal random variable with variance sigma square. So, 1 by n square, then sigma square plus sigma square, like plus sigma square, which will be n sigma square by n square, that is sigma square by n. So, that means using that, if I create a x bar, I told you if normal be distributed with mean of this, mean will be mu and x sigma square by n. Now, you are creating a z variable here. If you create a z variable here, so z is nothing but that x bar, this is the normal variable, minus its expected value of x bar divided by square root of variance of x bar. If any variable random any variable is subtracted by its mean and divided by the standard deviation, it is z standard value. So, what is this? X bar minus expected value of x bar is mu, we have already proved, and your variance is sigma square by root n. So, it is sigma square by, variance is sigma square by n. So, this is the quantity, or other way I can say z is x bar minus mu by sigma by root n. So, this will follow z distribution. Now, here in t case what is happening here, in this t case you see that what we are saying, suppose the x bar minus mu is there, but sigma is not known, you are using s. In z case, x bar minus mu by sigma by root n, this sigma is population standard deviation, but this is not known, instead you are using sample standard deviation in the t case. So, S is a random variable, but here sigma is a constant. Now, depending on the situation, ultimately what will happen, there are different conditions. If sample size is very large, then the same this quantity can be in unit normal also, but most general case is this quantity is T. Why? Because this quantity follows T distribution. How can you justify that this quantity follows T distribution? If you want to justify this, then I just rewritten this one. The same thing I have rewritten in this manner: x bar minus mu divided by sigma square by n, and then the square within square root component is n minus 1 s square by sigma square 1 by n minus 1. Just manipulation. What is that? The numerator and denominator is manipulated with some constants. Then what is this x bar minus mu by sigma square by n? This is z, already we have seen. This is z, top portion. What is the bottom portion? Earlier I have shown you that n minus 1 s square by sigma square follow chi-square distribution. You go back, you will see. What is this? This one, chi-square distribution. So, your resultant variable is that z value z random by the square root of chi-square by its degrees of freedom. So, it is T distribution, that is the use. Why you will use T distribution in this case? Okay. So, you see this formula and appreciate it, because if you understand this, huge problem will be solved. That is the use, follows chi-square distribution. So, the resultant quantity is this. Now, you require to use chi-square table. This is our chi-square table. So, please keep in mind, and in chi-square table also there will be degrees of freedom. Degrees of freedom coming into consideration because the parameter is degrees of freedom. The parameter of the distribution is degree of freedom. Okay. I think you will be able to find out. Suppose if I say that my T distribution with 11 degrees of freedom, and what is the probability, that means that 0.0025 if we consider, then you will be getting a value of 2.228. But if you see the Z distribution for the same thing 0.025, there is no need of any degrees of freedom, 1.96 will be the Z value. Okay. Then come to F distribution.
Sir, one question.
Please.
Sir, in T distribution there is a what student is associated.
Hmm.
Why that student
No, that is developed by that Gosset, I think. Yes, and it is developed while he was a student. So far I know this one. Student, that T distribution is
So
there.
the basic difference is that instead of using the population variance, we are using the
Sample variance. But population variance is still there, that n minus 1 a square by sigma square. Okay. But question is that but when we compute the T, there is no population variance. When you compute T, there is no population variance, S is there.
Yeah.
That everything can be calculated. So, now I want to know what is the distribution of this, and we found out that the distribution is T distribution. Okay. F distribution. Now, come to a ratio measure. What I am trying to, we will see here. Suppose you have two population for the same variable, population 1 and population 2 are characterized by the same variable, and you have computed, you have taken sample from both the population, you have computed your standard deviation or variance for population 1 as well as population 2. You want to compare whether variability in population 1 is different than the variability in population 2 or not, or they are basically equal. That means you are basically creating a variable which is suppose S1 square by S2 square. This is coming from population 1, this is coming from population 2. Whether two populations are having same variance or not, in many models we assume that the population variance are equal. For example, when you do ANOVA, even in MANOVA case also, we will be seeing that one of the condition for sometimes we use that population variances are equal. That means this ratio we want to require to know. In ANOVA you will be finding out the use of this enormous use of F distribution. In regression also you will be seeing. So, the ratio when your some quantity you are finding out, which is basically the ratio of two chi-square variable divided by their respective degrees of freedom. Then the quantity, basically this is what I mean to say, that if this is the W, this W, if we create like this, the quantity follows F distribution with 2 degrees of freedom, numerator degrees of freedom and denominator degrees of freedom. Why? You see the distribution here, nu 1 and nu 2, nu 1, nu 2, everywhere nu 1, nu 2 is there, rest are gamma function basically, other cases. So, getting me? So, this distribution is characterized by numerator degrees of freedom and denominator degrees of freedom. And when do you use F distribution? When you derive any quantity which is the ratio of two chi-square variables, and definitely that ratio, weighted ratio, ratio means weighted ratio of two chi-square variable, where weight is nothing but the degrees of freedom, 1 by that degrees of freedom. You are getting me? For example, what I say, let us see the use. Let us see the use. See S1 square, S2 square from two population, that population variance is sigma 1 square, sigma 2 square. I can write this like this because all of you, we have already seen that n minus 1 S1 square by n minus 1 S square by sigma square follows chi-square distribution. So, that means this quantity will be chi-square divided by degrees of freedom. The denominator quantity will be again chi-square divided by the respective degrees of freedom, correct. So, this is W and this one is F distributed. So, in F distribution, please keep in mind, when we talk about F distribution, there will be numerator degrees of freedom, denominator degrees of freedom. So, when you go to see the F distribution table, you have to see the two different degrees of freedom. For example, if you are interested to know for 5 numerator degrees of freedom and 3 degree denominator degrees of 3 denominator and 5 numerator degrees of freedom with a probability value 0.025, then you find out this value, you will be getting this value 0.7, that is 7.76. Okay. So, this way it will be used, and central limit theorem is the final one for us today. Again we will discuss, next class we will discuss the sampling strategy. Today we will finish by this. Central limit theorem says that if you sample from normal population or other population when the sample size is large, then the distribution of x bar, the statistical distribution, that is the sampling distribution of x bar will be normal. X bar is normally distributed with mean mu, variance sigma square by n. Okay. So, there are many sampling strategies. First one is random sampling, stratified sampling, cluster sampling, systematic sampling. There are some other sampling, convenience sampling, all those things. Basically, we talk about the sample statistic. That means you have collected data. How you have collected data? Strategy means what method you have adopted while collecting the sample. Random means you will randomize the collection procedure in such a manner that each and every observation is equally likely to come. Okay. Stratified sampling is sometimes required. What happens? Suppose you want to see that at different age groups what is the pattern, suppose for a particular, suppose blood pressure pattern, then you will create young people, mid-aged people, old people, 3 strata you will create, and every strata you randomly select observation. Cluster sampling is what? Cluster sampling is, suppose you think that our exit poll this time for panchayat election in Bengal, there are in West Bengal there are so many districts, each district is a cluster. Suppose you cannot go for every district and collect sample from each district, you can randomize the cluster. So, that means you will select based on some randomization experiment, you will select some of the district. Suppose you select one district based on randomization and every voters on that district is sampled, then that is single stage cluster sampling. Now, it may so happen that you may go for 3, 4 or even more district at random, and again each of the district you will collect data from individual selecting randomly. Getting me? First one is district, number of district is there, you select randomly one district, sample everybody, that is single stage cluster sampling. Second is first randomize the selection of the district, take few district, and again in each district you randomize the selection of individual, that is 2 stage clustering. Now, if you again in district level you can go for city also, there one more randomization is possible. So, that multi-stage clustering will come. Last one is systematic sampling. Systematic sampling means you basically follow an order. For example, suppose the 10th day you will set a target, for example, suppose the kth observation you will collect in one sample, correct. Suppose the population size is n, sample size is small n. So, that and you want to, suppose this quantity is k, you want to collect a sample of n. So, what you will do, from the first n observations you may be at the nth point you observe, then you go on adding k, the second observation will be after you will select the L plus kth item, then L plus 2k item, that way you will collect the n sample. Getting me? So, these are the strategies, and you go through some books, and you know that as I told you that T distribution and F distribution will be heavily used, and F distribution all of you know that R. A. Fisher, that English statistician, he has contributed a lot in agricultural sector, and George W. Snedeker, American mathematician, they are the pioneer in developing the F distribution. Okay. In next class I will bring that student distribution, that particular person, because this will you can remember throughout, because you know Fisher and Snedeker, that they have basically developed the F distribution, Snedeker and Fisher. R. A. Fisher is a well known name.
Sir, reference was that
Montgomery and this Axel AD, Complete Business Statistics. These both books are very much available. Okay. And for multivariate statistics, Johnson and Wichan and Hare et al., that I told you in the beginning, please. Okay. So, next class we will discuss estimation, particularly confidence interval. So, okay, thank you very much.